Hi, today let's look into how we can find frequency in a linked list. So we are given a linked list and a key. Our task is to count how many times this key appeared in the list. So let's take this example linked list, say 1, 2, 1, 2, 1, 3, 1 and null. And here let's say the key is 1. So we'll traverse the list and count every node whose data equals the key. So let's first initialize the count to 0 and point current to the head of the list. So this is current. So the logic is simple. While traversing at each node, if the node's data equals the key, we increment the count. Then we move to the next node. So these are the two steps. So let's quickly dry run it. So this is the first node. The first node is 1. So count becomes 1. The second node is 2. It is ignored. The third node is 1. The count becomes 2. The fourth node is 2. It is ignored. Fifth node is 1. So count becomes 3. Sixth node is 3, it is ignored, and seventh or the last node is 1, so the count becomes 4. Once we reach null, traversal stops, and therefore the final value of the count is our answer. So the final value of the count is 4, so 4 will be our answer. Since we traverse the list only once, the time complexity will be big O of n, and we use only a constant extra variable, so our space complexity will be big O of 1. Let's also quickly look into the recursive approach. A recursive solution does the same thing. It moves to the end of the list. While returning, it counts matching nodes. It's more like a recursion stack, let's say like count of node 1, count of node 2, and so on up to null, which finally returns 0. So that's how we find the frequency of a key in a linked list. And for the recursive approach, the time complexity will be big O of n and the space complexity will be big O of n as well. Now let's look at the coding part for both the approaches. Alright, let's quickly look into the iterative approach first. So we are inside the solution class and we are defining a function count that takes the head of the linked list and key whose frequency we want to find. And first we got to initialize a pointer. Like I'll create a pointer called current and initialize it with head. So current is initialized to head. So this pointer will help us traverse the linked list node by node. And next I'll initialize a variable count with 0. So count is 0. And this will store how many times the key appears in the list. Now next we'll have to start the traversal loop. Now we'll have to loop through the linked list using a while loop. So while current is not none. So the loop continues until current becomes none, meaning we've reached the end. So inside the loop, we compare the current node's data with the given key. That is, if current.data is equals to key, if they match, then we increment the count by 1. That is, count plus equals to 1. Okay. Now we got to move to the next node. After checking the current node, we move the pointer to the next node in the list. So current will become current.next. Okay. And finally, once the loop finishes, count contains the frequency of the key, so we simply return it. So we return count. Now let's go ahead and run the code. As you can see, for these test cases, we have for key 1 we have 4 instances. We have 0 for the second test case, we have 4 for the third test case, we have 1 for the fourth test case, and we have 0 for the final test case. Let's similarly solve the recursive approach. We are defining the same count function, but this time we'll solve the problem using recursion instead of a loop. So this is the base case of the recursion. If head is none, then we return 0. Why are we doing this? If the linked list is empty or we have reached the end, there are no nodes left to check, so we kind of return 0. Now here we have to make a recursive call on the rest of the linked list. So let's say answer is self.count head.next and key. Okay, so this call will count how many times the key appears after the current node. Now we check the current node as well. If head.data is equals to key, then we increment answer by 1. The current node's data matches the key, we increment the result by 1. Okay, and finally we return the accumulated count back to the previous recursive call. So we simply return answer. Okay, now let's go ahead and run the code. So we've got the same output for the same test cases that we had earlier for the iterative approach as well. The recursion goes till the end of the list, and while returning back, it counts matching nodes one by one. So that is a recursive approach logic. And since among both iterative approaches, the optimal approach, use that in the interviews unless you're specifically asked to use recursion. Thanks for watching.